Have you ever wondered why ice floats on water? It's one of those everyday mysteries that we often take for granted, but the answer is actually pretty fascinating. And it's all about the science happening right under our noses. Think about it. You drop a chunk of ice in your drink and it just sits there at the top, refusing to sink. No matter how many times you try, the ice always bobs right back up, as if it's determined to stay afloat. But why? What's going on at the microscopic level that makes this happen? Let's break it down and see what's really happening inside that glass of water. First off, water is a pretty weird liquid. It doesn't always follow the rules that most other substances do, and that's a big part of what makes it so interesting to scientists. Most substances get denser when they freeze, not water. When water freezes and turns into ice, it actually becomes less dense. And that's the secret behind floating ice. It's a rare and special property that sets water apart from almost every other liquid on Earth. Here's how it works. The answer lies in the way water molecules interact with each other as they change from liquid to solid. Water molecules are like tiny little magnets, each with their own positive and negative ends. This gives them a special ability to stick together in unique ways. Each one has a slightly positive side and a slightly negative side. This is called polarity, and it's what allows water molecules to form hydrogen bonds with each other. In liquid water, these molecules are constantly moving and sliding past each other, packed pretty closely together. They're always in motion, breaking and reforming bonds in a chaotic dance. But as water cools down and starts to freeze, the molecules begin to arrange themselves in a very special way. The temperature drops and the molecules slow down, giving them a chance to line up in a more organized pattern. They form a solid structure, a crystal lattice, that holds each molecule further apart than when they were liquid. This lattice is what gives ice its unique shape and makes it less dense than liquid water. Imagine a network of tiny bridges holding the molecules apart, creating open spaces within the ice. That's why ice takes up more space than the same amount of liquid water. So what does that mean? Well, it means that ice is less dense than water, and that's why it floats. When things are packed closer together, they're denser. Think of marbles crammed into a jar. There's less empty space, so the jar is heavier for its size. But when they're spread out, like in ice, they're less dense. There's more empty space between the molecules, making the ice lighter for its size. And things that are less dense than water will float. That's a basic rule of physics. If something is lighter than the liquid it's in, up it goes. That's why your ice cubes always bob to the surface in your drink. It's not magic, it's science in action, right before your eyes. Now you might be thinking, so what? Why does it matter if ice floats? Is it just a neat party trick? Or does it actually make a difference in the real world? Actually, it matters a lot. The fact that ice floats is one of the reasons life on Earth is possible, especially for creatures living in lakes, ponds, and oceans. If ice sank, lakes and oceans would freeze from the bottom up. Over time, they could become solid blocks of ice, making it impossible for aquatic life to survive through the winter. That would make life way harder for fish, and all sorts of creatures living in the water. Many species depend on the liquid water beneath the ice to survive the cold months. Floating ice acts like a blanket, insulating the water underneath and keeping it warmer for the living things below. This thin layer of ice helps maintain a stable environment, even when the air above is freezing. And get this, water is one of the only substances on Earth that behaves this way. Most other liquids don't expand when they freeze, and they definitely don't float. Most other liquids get heavier and sink when they freeze. If you froze oil or alcohol, for example, the solid would drop to the bottom. But thanks to the unique shape and behavior of water molecules, our planet gets floating icebergs, skating ponds, and yes, perfectly chilled drinks. It's a quirk of chemistry that shapes our world in ways you might never have imagined. So next time you see ice floating in your water, remember, you're looking at a tiny miracle of chemistry, a quirk of nature that helps keep life on Earth possible. It's a reminder that even the simplest things can have a huge impact on our planet. Pretty cool, right? The next time you enjoy a cold drink, you'll know there's a whole world of science happening in your glass. If you learned something new, hit that like button and subscribe for more bite-sized science. See you next time.